Thanks for coming to the first lecture in the fall series. Thanks for all those joining us online. Just a couple order of business items here first. Bathrooms downstairs and upstairs, exits out the front door and to the rear there. And then folks that are watching online, if you have any questions during the lecture, please email idl@uidaho.edu to get your questions answered live. And then to those of you in the room, thank you for coming again. We have quite a good little series of lectures coming up this fall series. Tonight we're going to be doing post-occupancy energy metric basics with Allison Kwok from the University of Oregon. It's a pleasure to have her. But we'll also be doing the flavor of this year's or this fall season is the existing building renewal. So we'll be taking a look at existing buildings and how to reduce the energy use in existing building stock. On October 7th, we're going to host a fellow from Ideas, which is an electrical lighting design company from California, where they took a standard bank building, tilt-up concrete, kind of an energy hog, and turned it into a net zero energy building. So that should be pretty interesting. On October 28th, we have a couple of guys coming down from the National Research Council of Canada to talk about sensor networks in existing buildings and demand reduction in buildings, as well as calibration of building simulation models in buildings. On November 4th, we have Darwin Roy from Climate Tech, Mike Merningham, and Gary Christensen to talk about recalibrating the Banner Bank building for even greater savings. So that should be pretty interesting. November 18th, we'll be having brief presentations and kind of a panel discussion of local professionals and what they've been doing for existing building renovation and energy savings in this area in Idaho. So that'll round off our topics for this season. And then again, thank you to the sponsors of this program, Better Bricks, Idaho Power, Northwestern Energy, and I'd like to introduce Allison Kwok, professor at University of Oregon. She's written a couple, or is a co-author on a few books you might recognize: Mechanical and Electrical Equipment in Buildings, a Green Building Studio Handbook, amongst others. And so with that, I'll hand it off to Allison.
Okay, well, thank you and welcome. Thanks to all of you for ordering this beautiful weather. I think I overdressed. It's so kind of cloudy and drizzly and 49 degrees this morning when I left Eugene. So this is wonderful. Thank you. And thanks to Better Bricks and IDL for inviting me. This talk really has come about because of not only my research work in post-occupancy evaluation and case studies, but also we're doing a small project with Better Bricks to raise awareness, bring some firms along in tracking and calculating their energy utilization index intensity for their buildings, so for past projects. So by looking at past projects and having a feedback loop and then moving forward to how you can improve and compare buildings to your firm's buildings to improve future buildings. So we're working with firms in the Northwest to do these calculations on a spreadsheet that I'm actually going to give you the tool or give you access to the tool and explain a bit of it in the lecture this afternoon. So I hope it's not too academic, but I'd like to start off first with hearing a little bit about who you are, what your affiliation is, and if you could also think about and tell us what is the most energy intensive appliance that you've ever used. So I'm going to let you think about that a little bit. As Gunnar mentioned, I've taught at the University of Oregon for 12 years. I was teaching on the East Coast before that. Grew up in Hawaii, where natural ventilation is great potential for natural ventilation. I did not even know what a thermostat was until I moved to the mainland, and I learned quickly that you have to move it up to get warmer. So, if we could start here at the daylight folks near the window.
I guess a bunch of us are students from the University.
Okay.
Here at the University of Idaho.
And your name?
I'm Kevin.
Kevin. And what's your most energy intensive appliance?
I have
No idea. Okay, we'll come back to you.
I'm Edgar. I'm also a student at IURDC. I'm not sure. I'd say maybe refrigerator.
Refrigerator? Maybe an old refrigerator?
Right.
Yeah?
Bill Bishon with Idaho Power, and I'm going to expand on the definition of appliance and say a helicopter.
A helicopter. Good. That has carbon implications too.
I'm Reed Shannon, I'm an architect, and I would say probably an old refrigerator.
An old refrigerator, yeah.
I'm Steve Wakeman, an architect, expanding the definition probably of my vehicle, my car.
I won't ask you what color.
I'm James Carlson. I'm at the University of Idaho. And I would say air conditioning.
Air conditioning, yeah, definitely.
Ron Whitney with the Northwest Energy Coalition. I'll go with the clothes dryer.
Mm-hmm. Gas or electric?
Well, I'd say electric for most energy.
Okay.
Inefficient.
I'm Ken Gallegos, I'm an architect, and I'm president-elect of AI Idaho. I'd say most either the air conditioner or the television,
Mm-hmm. Those big plasma televisions.
because they're both on off.
My name is Brad Aker. I'm an employee here at the IDL. So I'm going to go with my first thought, which was a hair dryer.
Cool. Yeah.
I'm Ron Politan. I'm a graduate student. And I was thinking, every time the air conditioner gets on, the lights dim, so I'll go with that.
Okay.
Jared Justin, I'm with the University of Idaho as well, a student. And probably go between the clothes dryer or air conditioning.
Clothes dryer or air conditioning, yeah.
Or electricity.
A lot of watts.
I'm Craig Kirk. I'm also a student here at the U of I. And it's either my TV or my desktop computer because they're both
On all the time. Okay.
I'm Lauren Lee, and I'm also a student. And for me, it's heating in general, hot water as well as this furnace because I'm doing it all the time. So I probably
Good. Thank you.
I'm Katie. I'm a student at the U of I as well. And I would probably go with baseboard heat. It's electric, so I would
Definitely.
I'm Will Cron. I'm a graduate student at the University of Idaho. And mine would probably be old furnace or hot water heater.
Good.
Greg Neruda with Smart Buildings 2030. For me, it would probably be a either or. Commercial oven, convection oven, or my new flat screen TV. Probably both.
Well, we could measure it. Find it.
I'm Dakota Goldson, grad student at University of Idaho as well, and mine would probably be my old refrigerator or my clothes dryer.
Great.
I'm John Neary. I'm also a student at IURDC. I would have to say probably an old electric furnace or boiler or something from that area. So,
Yeah. Good.
I'm Justin Johnson. I'm also a graduate student. Probably the air conditioner. It's used the most for me.
Steve Padgett, architect. I would say probably used a halogen work light,
Oh, yeah.
700 watt. That's how my energy bill will go up with construction. It's like smart.
I'm Doug Cooper with Kibbe Cooper Architects. I'd say our air conditioning
pure on condenser. And we try to only run it a couple days a year, but when it's on, definitely using a lot of power.
Eric, I'm a grad student at the University of Idaho. I probably have to say either an air conditioner or something along those lines.
Ty Caldwell, also a grad student at the University of Idaho. And I'd have to go with probably our old electric oven. Pumps out the molding right well.
Well, these appliances, as you can see, are not unlike buildings. How people actually use them and the occupancy and the amount of time all plays into it. So I'd like to start with a story. A couple of years ago, I had a class on a post-occupancy evaluation class on taking a look at a school in Oregon that had just opened, and we went to study it about a year and a half later, and there were the facility manager said, you know, the school is using a lot more energy than was predicted, and you know, it's a familiar story, right? And so, you know, we just don't know what it is. So the students organized into teams, and one team looked at the natural ventilation, and another team looked to see if there were lights coming on when they shouldn't, as a possible contributor, and another team looked at CO2. Oh, and another team looked at illumination. Was there good daylighting illumination on the desktops for the students? So the one particular team that hypothesized that there were lights coming on when it shouldn't, you know, we thought, well, that's probably not enough to contribute for these really high energy bills. But, you know, they went ahead and put those data loggers up into the lights here. And they turned on not only the lighting channel, but also a temperature channel, just because the data loggers had that ability. And what they found was that on the lower graph here, you know, the lights were coming on as they should in the morning. They were finding a spike in the middle of the night. That was around 2 or 3 in the morning. That couldn't be explained. It wasn't the custodial crew. It wasn't emergency lighting. But it wasn't quite enough to say that that was the reason for the humongous energy use over time. But what they also found out on the temperature channel was that the mechanical systems were coming on somewhere around 1:30 in the morning and staying, you know, getting to comfortable 72-degree temperature and then going off at the end of school. So, you know, something was going on. The building management system didn't track that. It was just the temperature in the entire school, not only the classroom, but the entire school was going up. So this was sort of a feedback loop to the architects, to the facility manager, to the school district, where the students were then gave some information back to everyone, and hopefully they have fixed the problem, but we have yet to go back and check. So it's a familiar story. So the talk today is going to be kind of past POE efforts, describe some definitions for energy metrics, because just to give a baseline, describe some tools that are out there, and to describe the tool that I'll give you, and some of the sample projects. Maybe I'll sit down, so I don't need to stand. So in the past 20 years, there have been quite a few kind of case study efforts, curriculum efforts through education. The Vital Signs Project started in the early 90s, and that was coordinated out of UC Berkeley. Agents of Change Project was one that I got funding for from the Department of Education to implement case studies in architectural education. Certainly the Solar Decathlon effort, AIA Case Study Initiative, 2010 Imperative, 2030 Challenge. And these projects are still, although they're not actively funded right now, they are still available on the web, where there are model case studies, lists of the kinds of tools that are available, and actually the vital signs case study still has something like 10 to 12 resource packages on various topics like HVAC systems and components. And it'll go over the principles or the concepts, but the bulk of those resource packages are a step-by-step protocol of how to go into a building and take a look at it at kind of a level 1 observation, level 2 gathering data, level 3 monitoring. Agents of Change project followed that project for about 5 years and spawned all sorts of workshops that brought faculty together with their graduate students so that folks could get trained on how to do a case study and then go back to their own institutions and bring that into the curriculum. In fact, the last time I was here, we did kind of a one-day event, tool day event at the Banner Bank building. Was one of the projects. So these case studies use a building in use approach. The idea is to get folks into real buildings. Maybe it's a novel concept, but go into actually real buildings, look at the design intent and actual outcome. Does the intent match what the outcome is? And there's stories in every building. We have our students at the U of O develop a hypothesis as a way of bounding the topic and to develop an appropriate methodology, analyze it, and then share it either as a paper or on the web or in presentations. So, as I mentioned, every building has many, many stories, but some are a little bit more interesting than others. The Monde d'Arabe in Paris has that thousands of apertures that open and close according to the sun. And has anybody been there to see if they still work? About 5 years ago, I went there and stood just to watch to see if they were moving, but parts were not working and parts were. But it's a beautiful, beautiful building that synthesizes technology and performance. Chesapeake Bay, these large cisterns, are they adequately collecting water? There are composting toilets in this office. There are only composting toilets in that office. There are no regular toilets. So how have the occupants actually adjusted to new ways of bathroom behavior? These shades on the building, these are kind of Teflon impregnated shades. Are they functioning as they were intended? I believe these are on the west side of the building. And this is right up here in the northwest in Seattle. This is the roof of a garage and a dance studio. It was done by Miller Hull. And we actually monitored this to see how the green roof was performing as an insulative layer and as a way of reducing heat island effect. We went there with the architects and we were using handheld tools, the Raytec temperature sensor, and the roof was 154 degrees Fahrenheit, and we all were just stunned. I mean, what happened? The data logger measuring the moisture in the soil actually exploded, and the solar radiation hit it and all the batteries melted, so we didn't get data on that. This is the Biodesign Institute at Arizona State University, and during the design process, the shading on this side of the building was value engineered out. So how is that building performing? You know, you can see the shades are drawn in much of that wing. The EUI, which I'll be going over for this building, is somewhere on the order of 360 kilobtus per square foot, which you'll know is a very, very large number. It's a laboratory building. We're going to go over that in the near future. So in our effort to go into buildings and actually take a look at what's going on, the lab here has quite a few tools that have, you're building a collection, and the tools over time have really, really come down in price. The data logger, these hobo data loggers that you've seen, 10, 15 years ago, to do temperature data logging was very, very expensive, and now with the price of these small data loggers you can get them for $50, $75 with software, so that you can launch them and put them anywhere that you want for a week, a day, a year. And I brought some tools just to pass around, and I don't know if I can reach, my cord will reach, but you can pass that around, and there you go.
Do they work?
Yeah, they work. These work. Yeah, don't point the laser at the eyes, but as you pass this around, there are three Ratex that are going around, which measures this temperature, which measures the temperature of the surface of that material. And actually, for those of you that have it, go ahead and measure the glass and the floor, and what are you getting? 86.5. 86.5. Okay, and the floor is
79.1.
70. Okay. The ambient temperature is 79.1. And as the Ratex moves back, if one of you, I'm just curious, if one of you could go and measure, just step outside and measure the temperature of the sidewalk. And then report back what you got. Because I measured it earlier, and it was quite hot. So now that the sun is sort of going down, I'm just wondering what the thermal mass effect is. So these little Ratex, they're about $60 or so, and they measure. They're set at an emissivity of 0.95, which is what most materials are. If something is super shiny, like a piece of metal, or very reflective, the emissivity is much lower. So it really measures that material property of emittance. So, well, we should. They may not come back. They're gone. Sorry. Come on back. Okay, so you did a little.
Ambient, right? Is this what this says?
That's ambient, right?
83.5 in the sun and 76 in the shaded part of the sidewalk.
On the sidewalk? Wow. Okay, it was a lot higher. It was close to 90 earlier today. Well, thank you for the field trip. Okay, so obviously, for what's extraordinarily current in terms of helping reduce energy use in buildings as well as the carbon emissions is to really take a look at the energy use in our buildings. So, so we have a term that's been used quite a bit and is used as a baseline reference guide for a building's energy consumption. So this takes into account the energy inputs into a building. This can be predicted or actual. So if it's predicted, it's going to be simulated, modeled. And if it's actual, you're going to use the actual energy data, utility data for electricity, gas, propane, biofuels, wood chips, you know, anything that goes into it, and divide it by the square footage of the building to yield the amount of energy per square foot over the entire year. Now there's kind of a lot of, that sounds very simplified, but you know, when you talk about square footage, what kind of square footage are you talking about? So different tools take into account different spatial conditions. So it might be gross square footage, which measures to the outside dimension of the exterior wall, or gross measured square footage to the inside of the exterior wall. So it really depends on the spaces as well as what sizes are specified. Of course, what we're really concerned about are the carbon emissions that are a result of that energy. So when we're talking about CO2, it is it's not specifically CO2, but it's an easier way to talk about emissions of all sorts in terms of carbon. This data was taken from the Paul Torsellini's report on the source and emissions factors, which is available online. And it gives a lot of these conversions. So when you're talking about gas, and the unit of gas that we get in our utility bills are therms, one therm will produce approximately 13 pounds of carbon dioxide. In turn, that same amount of gas converted to kilowatt hours for electricity, that will produce 35 or 36 pounds of CO2 in terms of emissions. And so in terms of getting to the 2030 targets, this is where we want to reduce our target emissions, hopefully to neutral, to zero by 2030. Yes, one therm is equal to 100 kilobTUs and then 29.3 kilowatt hours.
What about hydro power? What are the assumptions with that?
So the assumptions on that are they've taken into account regions. So there are regional factors depending on what grid, and it's an average over that region's
Grid efficiency?
Yes. So there is it 5 grids? There are 5 major grids? Right. So West Coast, East Coast, Texas has their own, Hawaii's on their own, Alaska. Yeah, go ahead.
I've never seen an analysis of the inefficiency of the gas distribution system, the transmission and the distribution. They use gas turbines to compress at the transmission level. They use electric motors to compress the distribution.
So the losses.
Yeah.
Right.
Yeah, just like we're doing with the electrical grid. That's
Right.
never accounted for in the gas.
And I
they're
don't
always-
know
but
if
they're
it's
also-
not accounted for in this article. I'd have to look back at it.
I've never seen it, I'm looking for it.
Okay, so once you actually have an EUI or you have something calculated, what can you compare it to? So CBEX it stands for the Commercial Buildings Energy Consumption Survey, and it's updated about every 4 years. It does not include parking garages, residential buildings, or any buildings that are lower than 1,000 square feet. But in about 3 years ago, the AIA, ASHRAE, USGBC, the IESNA combined to agree that they will use CBEX as the document to compare buildings against that reference, to use that as a standard and as a common starting point. The other, well, you can compare it to many things, but the other benchmark that can be used is from the DOE, from NREL originally, and it's now called the Commercial Reference Building Database. And I'll give you the URLs for these. But what I like about this one is that it has numerous models in 16 different climate zones. And they're categorized by vintage. So there's new buildings, there's a category of buildings that are pre-1980 and then post-1980. So as we start to move towards retrofitting existing buildings, which is huge, this is an important way to compare them. They've also, it references ASHRAE 90.1 code, so the most up-to-date code. So it adds HVAC, lighting, people, and plug loads. So this is completely not readable, but it's one of the charts from CBEX that you can access through Energy Information Agency, through DOE. And these are the energy intensity for basically major fuels by region. So you've got the Northeast, Midwest, South, and West. So it's general, but it's a good starting point. The DOE commercial buildings. This is just a screenshot from new construction, and this is dated May of 2009, and you can see that lots of different building types as well as these climate zones. So I mentioned the 2030 challenge, and this sets targets. They say they set reasonable targets to reach carbon neutrality by 2030, and it's a way of stepping down very quickly in order to be self-reliant and off of fossil fuels. So there are a few tools to get there. There are many firms that are designing their own tools, in-house tools, and there are a few that are available online, publicly. The EPA Target Finder is, you can go in there and put your building in there and set the region and get very general targets based on the CBEX data. The EPA Portfolio Manager is a way for firms to gather information and track their own projects through a series of projects. So if you specialize in schools, there's a way to track the actual energy use, and they're bringing in water consumption as well. In June, the AIA, shortly after the Miami meeting, has developed this tracking tool, not unlike the portfolio manager. It's an easy to use. Have you had experience using this? No, it's an easy to use tool that it's Excel-based tool, and you input your you can input predicted or modeled data, and then you check off whether you're intending to actually monitor and gather data. So it's trying to encourage people to really take a look at their own projects. The carbon neutral design tool is an Excel-based spreadsheet that will make available to you. It was developed by Mike Utzinger, who has spoken here before, professor at the University of Wisconsin-Milwaukee. And academics have time to kind of dig into this, and so we're trying to help the profession use this as a design feedback tool. So you put in actual utility data and area takeoffs for your building to get the EUI and other metrics. So in general, he has categorized these into a level 1, level 2 metrics. Level 1 metrics are really based on general building information, the utility data, some construction costs. It's based on sort of gross square footage. You can, with all the data gathered, you could probably do the calculation within 30 minutes, 45 minutes. The gathering of the information takes a little while. And then for level 2, these are really where the design variables come in. So for level 2, you're putting in enclosure information. So what's the actual U values, R values of the wall, the kind of the heat transfer rates, and some of the actual connected loads in terms of lighting power density, fan power, pump power. Probably have to work with the mechanical engineer on this. So what we're going to hand out, actually, I can pass out, could we do on that side? Thanks. Just go ahead and take one packet, so the yellow sheet and the white sheet. And the level 1 has basically 3 tabs. So the first worksheet is where you enter in the building information. So the gross floor area, the measured area, the major vertical penetrations. Got to do a lot of area takeoffs to get in the actual size of the, oh, sorry, did I? Okay, is it? Scratchy. Okay, thank you. There are the design costs, if that's available. Most of the times it's just construction costs. So we're not just doing basic EUI. We're actually setting up the firm to be able to look in depth at more metrics than just energy use per square foot. The second tab is where the utility data is entered. And so you get your energy bills for the project. It can be, you enter the electricity, any renewables that are in there, propane, natural gas, biofuels. There are places to add that into each of the cells. Monthly data. And then the third tab is calculated. This is takes the data from the first two sheets and gives the energy use intensity in both IP and metric, and then also calculates the carbon dioxide emissions from the different fuel types, and then it'll give you the full net fuel emissions. Water isn't usually tracked, but there's an area to input that as well. And to give a metric for that. Also occupancy, how many full-time employees are there in there? That has a huge effect. And so on this sheet, if you could take a look at the yellow sheet gives the first tab is on one side, and on the other side there are the actual resultant metrics. And so on the IDL website, they have posted the blank spreadsheet, and then also a level 1 and level 2 filled in completed worksheet for the Aldo Leopold Legacy Center. On the white sheet that I've given you, this is just an example of how you could take some of that data and present a very brief case study and the metrics. So this is Rosa Parks School in Portland, Oregon, and the EUI was calculated for that, the level 1 and level 2 metrics. So that's just an example of how what the actual output is like. So just want to give you that. So the IDL work, is that live now, or?
Yeah, if you're on the video link, the page, they're at the bottom there. You can just download them, they're Excel sheets.
Okay.
And so for you guys, if you want to get them later, just go to the same video link for this session, and you'll see the attachments at the bottom there.
Yeah. So the blank spreadsheet is for level 1 only. And as soon as Mike has updated and gotten all the level 2, he's just added a few more cells and rows. We'll send the updated sheet to you so you can have the level 2 calculations as well.
So this data, you only have to enter the level 1 page stuff, and it calculates all the rest?
Yeah, yeah. So you just input into the first tab and the utility data into the second tab, and then on the third sheet you'll get all the metrics coming out. It sounds very simple, but I'll tell you, as I mentioned, to do the level 1, once you have the information gathered, it's very, very quick. I mean, if you're really fast at entering, you can probably enter it in 10 minutes. It's the gathering of the data. To do the level 2 metrics, it takes a bit of time to do those area takeoffs and get all the information for wall details and fan power and pump power and the connected load. So if you're really quick at reading the drawings or know where to access that information, then it's fairly fast.
You'll be using that same information on your comm checks generally, so it's a lot of times it's already broken out for you.
Yeah, it's usually there. It's just finding it. Right. Mike has also included one of the updates is separating out the parking garages, because the former spreadsheet included these large parking garages where there was usually very little energy use in those garages, which can skew the whole EUI. measurement. It can make it look a lot better than it really is. Okay, so what can you use this information for? Oftentimes these metrics are now required as part of, let's say, the AIA Top 10 Code Awards. I was on the jury for that, and I can report that the jury did look at the energy metrics and all of the 10 metrics, but very, very carefully on the energy metrics. So they can be used in your design competitions or design entries, marketing materials in terms of how you've benchmarked your own buildings. You can certainly, hopefully, use it to improve design. And just very recently, the city of Seattle has the energy disclosure ordinance that all buildings over 50,000 square feet must report their energy use for the past year, starting of April 1st of next year, and that all residential and multifamily housing over 10,000 square feet must report this in April of 2012. So it's kind of coming down the pike, and we need to have a way of measuring it. Yeah.
Do they need to report their square footage also?
I think they have to. Yeah. I think it's incorporated into that.
Do you already be following suit for large buildings as well in Vancouver, BC?
So Seattle's sort of blazing the trail there. Huh?
So is that to just gather data, or are there some repercussions?
Gather and report, right?
And yeah, Seattle's actually going to be using it as a code enforcement. So actual energy use enforcement of the code. Down the road. That's further down the road. First they're collecting and just getting that worked out, and then they'll.
Okay, so very quickly, I just want to show you what described through the Aldo Leopold Legacy Center what Kubala Washatko had done to kind of target, to set goals for their own project. This was completed a couple years ago. It was LEED Platinum, and at the time it received an innovation and design credit for carbon neutrality. And Mike Utzinger, the one who did this spreadsheet, was the consultant on this, and worked with the architects on setting these performance goals. So they looked at high-performing buildings, at a variety of high-performing buildings. They looked at Oberlin's building, the Chesapeake Bay Foundation that I just showed, sort of the code office building here. And they set McDonough's Woods Hole Research Center as their target that they would like to meet or beat that performance. And you can see that it was around 15, 16 kBTUs per square foot per year. So they set a pretty stringent target for themselves. The building itself is fairly elongated. It has a lot of daylight perimeter zones. They broke out these other buildings this is the three-season hall that actually floated and does not have any mechanical systems. And they really zoned each area of the building. This is sort of a conference meeting hall that can be shut off entirely when it's not in use. These folks had also moved from another location into an area that was sort of outside of the city, so they also took into account their transportation and carbon emissions. from getting to work, for everybody getting to work. There's natural ventilation and daylighting. They selectively harvested and tagged every single tree on the site. And for the trees that were selectively harvested out, they reused all of that material and within the building, in the gallery space particularly. And you also calculated the shading and made sure that the windows and walls were shaded. And this is sort of that thermal flux zone. It's a transitional space between the offices here and the outside here. So it's a lovely space, passive solar. And so when they actually measured their EUI, they came up with, they didn't quite beat their Woods Hole target. They did on electricity, but not overall. This was their year one. They were close to 25 or so kilobtus per square foot per year, and that was because in the first year of occupancy, there was the largest snow that they've ever had, and all the photovoltaics were covered in snow for quite a bit of the year, so they had to implement some maintenance effects of taking the snow off the PVs, and so they performed a little bit better in the second year. The story really changes when you start to look at carbon emissions. So if you take a look at these EUIs, let's take a look at how the things stack up when you look at carbon emissions. So in terms of carbon, this was their simulated, this was their first year, and this was their target. So EUIs don't tell the whole story. Really, their success was in their renewables, in their using photovoltaics. Denny Park Apartments in Seattle. These are 5 stories above retail. This is affordable housing. Mike had put these apartments through these energy metrics and just wanted to see what affordable housing was, how that was performing. It can be done on a per unit basis, which is really useful in the spreadsheet tool. And how they came out was it wasn't bad. I mean, 35 kilobtus per square foot per year, and their carbon emissions were about 7 pounds of carbon a year. And then on a per apartment basis, if you want to break it down further than that, it's available. So if you're working with affordable housing, there is a way to do that. It's especially useful if the housing is all metered under 1 meter, but if it's multiple meters, then we've got to put in the data for each unit. So I think we're really at a crossroads. Do we continue to build these glass box buildings, or can we look at ways to temper the exterior environment with transitional spaces and ways of adapting our living or adapting our behavior to the climate? These are some fairly new buildings in China. Lots of reflection. Did anybody see the article it was in what? You know which article I'm going to talk about? It was about in Las Vegas, about this guy was out at the pool and there was a reflection from another building, and it was it had burned his hair, and it had melted a plastic cup or bag nearby.
There's an optical effect from some curved glazing.
Yeah, it was so reflective.
Like inks.
Not unlike the Disney concert hall in Los Angeles that reflected so much sunlight into the neighboring buildings that even after closing the buildings, it was like 135 degrees in the apartments. So are we really creating buildings that are really comfortable for people? This is an old building in Hawaii, in Honolulu. It's the Ala Moana Shopping Center. It has this long face that faces east and another long face that faces west, and vertical louvers that are on motorized shades. And several years ago, they decided to go through a facelift. And agreeably, it probably looks a whole lot better, but these overhangs do not take care of the east and west sun at all. Actually, I contacted the managers for the building, and they said, well, we can't give you anything unless it's on letterhead. So I wrote a letter on University of Oregon letterhead and said, you know, it's for educational purposes. Could you describe the rationale for going through such a change, and do you have any responses have the energy bills changed at all? And I got back a very formal letter saying, due to security, we cannot answer those questions. So I think in the cycle of how we learn from buildings, from a formative time in a student's education to the design profession to learning about buildings, I still think that we have a fairly large gap from buildings back to education. And so I just am making a plea to continue to feed the profession, but also feed education with learning about buildings, and to synthesize design and technology together. Some of our best efforts are retrieved with low-cost tools that you've all used. And it can tell amazing stories. This is back to the school that I introduced at the beginning of the talk, of what the actual illuminance is like in a classroom. You can see that on a clear day versus a cloudy day, what these foot candle readings are like. So you can see that this is very overlit in this area. This was a tool day that one of the professors at the University of Idaho and a number of us did at Arizona State University last May. And each team decided on what they would investigate. One team went down to the basement to take a look at the HVAC systems. They noticed that there was a hot water supply pipe, and I drew these arrows on there, but they were actually marked. Hot water supply was going down here, hot water return was going up there. So this wasn't their study, but they were kind of curious because they put their hand on the insulated pipes, and then they also put their hand on the metal ring at the bottom. But by touch, they noticed that this was cooler than the hot water return. And they said, well, you know, this doesn't sound right. So they got the drawings from the architect, and they said, sure enough, you know, hot water supply is here, hot water return is there. It's marked on the drawings as such, it's built like that. But then when they got the infrared camera, this side was about 12 degrees warmer than the other side. And it was just like, wow, man, what's happening? You know, so they went to the architect and they said, look what's happened. And he was all, yeah, stuff happens. He said that was nothing compared to everything else that had kind of needed correction in the building. So, but it's through these kinds of very short visits. This was 3 hours that they found this information. Can feed back into the system. Yes.
Do you relate those studies to commissioned versus non-commissioned buildings?
Yes. Well, on these short one-day visits, unless we have immediate feedback on what the commissioning, this building was actually still under commissioning. It's just opened, so it was probably a little too early to do a study until, you know, we really like to visit these buildings after the building's kind of gotten the wrinkles out. There was the National Audubon Society headquarters in Manhattan. One of my classes did a case study of that building. It was a while ago. It was in '97. And the team was looking specifically at the lighting. And they came up to me one day, the next morning after installing all the data loggers on the various lighting levels. And they said, Allison, the lights, we went by the building at 3 in the morning and the lights were on our floor. And I said, well, check and see if it was the maintenance. No, not the maintenance. Check and see if it was emergency lighting. No, not the emergency lighting. Check to see if the data loggers were broken. They were positive that maybe the data loggers were broken. He said, no, it's not that. Well, the lights had actually been on one of the floors since the building was renovated. So they were on, going unchecked for 5 years. So probably not totally unheard of, but a back of the envelope calculation calculated that it was about $15,000, you know, for that kind of unchecked. So on that building, we actually found somebody that could commission and would do it pro bono, but they had more things to worry about at the time. So since then, they have moved. The National Audubon Society headquarters has moved into a LEED Platinum commercial interiors space, also in Manhattan, but not in the same building. There are other tools. The Center for the Built Environment at UC Berkeley has an environmental quality survey and a huge database. So you can purchase this tool to be given to office building occupants to take this online survey. It'll ask questions on different aspects of environmental quality, air quality, lighting, spatial satisfaction, and it has several kinds of output that you can look at that building's data against their database of thousands of data points. And so you can immediately see where the problem areas might be. This is cleanliness and maintenance. This building really functioned well on this 0 or neutral line. The outliers, and I wouldn't even say that these are outliers. This is a pretty good, pretty successful survey. The outliers might be acoustic quality. A -1 is not too bad. I think if you're in this range, it's not so good. But in offices, that might be due to open partitions. In the Audubon Society headquarters, a lot of effort went into making sure that the daylight was being used in order to reduce energy use. But in terms of acoustics and privacy, the occupants could have cared less about daylighting. You know, they said, I want a private office, I want separation, I want to be able to be on my phone, meet deadlines without anybody bugging me. So we did the same survey in a building in Oregon that had a very similar open office layout. We got 100% feedback from every occupant. None of the data loggers were stolen or smashed like they were in New York. And everybody was happy. They said, oh yeah, if you want to come over and talk, no problem. So I think office culture can also influence environmental quality and satisfaction. This is another way of displaying the output. It's sort of like a windrose on satisfaction. I think one of the best ways to spur technology and design integration is through competition. And the Solar Decathlon has been going for, I think the first one was in 2002, so it's about 10 years. This is a recent run-through of a few of the projects. This was a prototype for affordable housing by Rice University. And all of these buildings have to function to a net zero target. Cornell had this kind of silo theme going. Very, very difficult to design in circular spaces. They had a lifted bed. Of course, the Team Germany won first place again. They had a series of photovoltaics that were under this glass shingle. Actually, I think the 11.1 kilowatts, I think it was 18. Other schools were saying that they were just a power generator. They actually blew a transformer on the mall when they plugged into the grid. This is a recent building on the University of Oregon's campus. It's a double skin building that's on a reflecting pool. And we just finished monitoring it to see if, oh, actually this is a learning center for the athletes. So there's been a bit of, people are very proud of the building. It's a beautifully detailed building. But there's also been a lot of comments about how nice a building it is for the athletes that need to come in for study hall. So we're in the double skin right here, and on July 6th, a couple of graduate students measured the airflow in there. They wanted to see whether the stack effect was really happening. So hot air rising, just as we teach in schools, hot air rises and goes out through the vents that are at the top. Well, one of the graduate students bought these 4th of July smoke bombs. And anyway, we put them at the bottom of there's a trough that goes around the outside of the building, and put them at the air intake. And the blue smoke shot out of the intake rather than going in as we all thought it would. And we're standing there going, what's going on? We had a professor up at the roof waiting to see the blue smoke, and another student at the second floor waiting to see blue smoke, and they just kept waiting because the blue smoke never came up at the top. Well, what we think happened is that because of the prevailing wind conditions, predominantly being from the north in the summertime, that the one side acted as a scoop and brought the air down. And on the other side, it acted as suction, so it helped pull the air up. So the verdict is not out yet. We did blow bubbles in the cavity too, and they all went down very fast. So, we have a lot to learn in buildings. Oh, and this is totally off the record, but the building is using 3 times more than was simulated. So it possibly could be because the simulation, the modeled, said that the building would not be used for 2 to 3 months of the year, but of course it was used all during the summer. It was packed during the summer. People are very excited about it. And also that the shades were not installed, so this was getting direct radiation, running air conditioning 24/7, and the reflecting pool has a 16-inch pipe that water is pumped through to make the reflecting pool very within 1/4 of an inch of the sidewalks. So it's a lot of water, it's a lot of fan pump power, it's a lot of air conditioning, and a underrepresented predicted energy use. So we have a long way to go. So I end with this, and I hope that I actually hope that we could have a little bit of a roundtable or questions to see what you all are doing in your firms. Is this a hot topic? Is this how is it being handled? I'm just curious. What are the questions or the barriers? I mean, we've certainly encountered a lot of barriers in our own small research project that we're doing. There's a lot of sensitivity in terms of giving out energy data. Folks don't want to have a bad rap. So even folks that want to find out about energies and share the information, it's actually taken a couple months to get some projects going, just to walk people through anonymity versus sharing the data. Anyway, thank you.
Yeah, if anybody has any questions, please go ahead and pass the mic around. And then otherwise.
Or if there are any questions online?
Yeah, I didn't see any yet. So.
Okay.
Are there any buildings in Idaho that have undergone this matrix?
No, but we're open to taking a few projects. I'd love to do that if we can gather the information. That'd be awesome. I'll give you my card and we can talk.
Probably not, but I'll just kind of.
Now, I'm interested in starting to track our firm's work with the 2030 challenge.
Yeah.
And so far we've, I'm not sure what the data means, but the best we've done on our energy performance is 42% below code.
Wow.
But I don't think that is the same as the 2030 challenge metric. And so I wondered if you could tell us what the difference is.
42% below code. Let me, where is the, so the question was, is that, the target here is then to, by today, by 2010, we should be working at 60% below code.
So that's what the 2030 number is.
Yes.
It is how far below code.
I'll throw in something
Yeah.
there too, is that the language in the 2030 challenge does state that it's a fossil fuel-based fuel. So I'll pick on a U of I building. If we look at the water center, you wouldn't count all of the heating energy that we're using from geothermal sources because it's a non-fossil fuel-based.
That's good. Yeah.
Source.
Good point.
So that's one of the little caveats, and it's always really difficult when you say 42% below code, but then you have an issue of which code version it is, or which ASHRAE 90.1 version it was done under. It's always kind of a moving target, and I believe that was really one of the impetus behind everybody kind of agreeing that CBEX 2003 would be something that as a solid measurement against.
Yeah.
You get a benefit from the fact that half power is
I think they do. I can't remember the basics, so I wouldn't pin it to me.
I think so. I think so. I can say that in the coat jury that just happened this year, that the metrics that were coming in were all over the place. Some were using different years of the ASHRAE standard, and some were reporting it. They were just reporting it in different ways. And so what the committee did was, not the jury, but what the committee did before the jury met was to send out all that data to 7 different experts all over the world, actually, and to ask them to help normalize that data so the jury could actually try to compare oranges to oranges and apples to apples. But that's a good question. I think that there is probably a lot of confusion in the profession about what are we really measuring, and in what depth are we measuring it. And so I think that's one of the advantages of this spreadsheet, is that it goes into the tool that is available, is that it goes into kind of a little bit more depth so that you understand the assumptions that are made, instead of just assuming that it's going to be this and when it's really actually this. And being able to answer that.
I'll offer that we've been doing an internal investigation of about 50 projects that we've been working on collecting energy data, back to 2003 and 2004. And it's certainly definitely the hardest part is getting the information. Calculating it's probably a lot easier, and we are even we struggle with which baseline. So we currently have something of about 20 different baselines to look at to see what the difference is.
Yeah. When we did a workshop in Portland in February, we didn't have anything to compare it to in the Northwest. If we did a workshop here, I'd definitely want to have some Idaho buildings, and folks were very engaged with the issue, but they said, we don't want to hear about that building in Wisconsin or California. We want to know how our stuff is comparing. So I was on a tear just to get some money to actually help a few firms get a critical mass of, let's say we could do 2 or 3 buildings for you, even just to level 1. We'll do that for you. But it's been slow going. The spreadsheet does not contain a tab for plug loads. This only takes utility data and the actual, plug loads, as you know, could be anywhere from 15 to 20% of the energy use. It's not regulated, right? The architect for the Ideas building actually, I yeah, it's the architect for the Ideas building, but it was on a different project. So it was EHDD out of San Francisco. Actually worked with the client to say, we are going to measure all of your plug loads before we even design the building, so that when you are, so we get a really solid idea of the equipment and how you're using it. So they worked together on it, and then they actually had the client sign, this is all hearsay, but they had the client sign something saying that, you know, we're in it together. But I think that's really powerful. I mean, I think we have to show that we're interested and engaged and committed to that effort. We're going to do a plug load survey right after this, right?
Yeah. Yeah, that's, plug loads are one of the things when you look at energy models that just like schedules and occupancy, you know, change after the model's been done.
It's this word that didn't even exist, you know.
Yeah.
Plug loads. What are plug loads? You know, it makes sense when you think about it, but if you've never heard the term, it's like, what are plug loads? But actually, at U of O, we just started classes just 2 days ago. I know that you've all been in session for a month or so. You guys are so lucky. But we just started, and one of the first assignment that I give in our environmental control systems class is not only carbon footprinting, but to do a plug loads. You know, how much energy do you actually use in your household? When people are there, you know. Anyway, any other questions?
With that, I guess we'll sign off. Thanks all for coming. Thanks to those who attended online. If you didn't sign in, please do so, especially if you need some AIA credits. And then we also have a few things in the back. The Idaho Association of Cities Energy Conference that's coming up at the end of October, I believe. We have some sign-ups for that. And there's also actually some scholarships for that too, so you may be able to go for free. Just check into it, but
yeah, I have one more thing. Well, this is totally off topic, but the houses that are built to the passive house standard, have there been any trainings or anything in Idaho yet?
no Idaho trainings yet. but there's interest.
Perfect climate for it. Anyway, the Passive House Conference, National Conference, is going to be in Portland, November 4th to the 7th. And I can say for students, they're giving a phenomenal discount. It's $475 for the conference, which is about on par with what a lot of conferences are, but for students it's $135. They probably will have to turn away people. There was an article in the New York Times 2 days ago about a house built to the passive house standard in Vermont that has no mechanical system. So it's pretty phenomenal. Super tight, super insulated.
European passive house
Yeah,
concept?
yeah. So Passive House has U.S. is based in Urbana, Illinois, and Katrine was part of the European, and she started Passive House U.S. So it's going to take off here though. Once there's some passive house it's amazing. Not to have any mechanical systems. It uses a ERV or a HRV, and usually with an inline duct electric resistance heater for those times where it just drops below. I can tell you that I was in a retrofitted passive house. Actually, it didn't quite meet the passive house standard, so he didn't go for certification. But it was in Eugene, and he got some passive house enthusiasts together for dinner, and he has 2 big black dogs that are really stinky before the renovation, and you don't smell the dogs at all. You couldn't even smell cooking, which is not a good thing. but it's so well ventilated, and it was very, very comfortable. I mean, it was almost maybe a little too warm with eight or nine people in there. But pretty exciting. Well, thank you. Thank you for staying.